welcome to your latest math lesson. We have one simple goal today to identify lines of symmetry. And this still goes along with our PA standard that we're working toward understanding and applying congruence, similarity, geometric transformations, using various tools. So let's review what we did in the last lesson. We talked about shapes. They have the same shape, but the size is different. These are 3 different squares, of course, and they are considered to be similar because they are the same exact shape, but they are different sizes. The next thing we studied last time was congruency, figures that are the same shape and the same size, and that is what we see in these last 2 slides. Triangles that are the same shape and size are considered congruent. And we also learned that their angles will be the same, and so will the angles on similar shapes, okay, or polygons, as we also learned yesterday. That was last time, that was a big important point too, was that the angles of similar polygons will be the same measurement. And we can use measurements from ones we know to figure out measurements in ones we don't know. So, question for you. Are these figures congruent or similar? Okay, another one. What about these guys? Are they similar? Are they congruent? Let's talk about symmetry now. That's what our goal is. And as you can see, this pine tree is a perfectly made pine tree. It's exactly the same on both sides, so it has symmetry. And the line that is cut in half with it cuts it in half perfectly to show the symmetry. And as you can see, letters are sometimes symmetrical. There's only some that are, but the A can be, depending on how we cut it in half. And our faces. The more symmetrical a face is, the more what the world would say is a beautiful person. But I just think the dog is the most beautiful. Isn't she adorable? Don't know who she is, but she is beautiful and very symmetrical. But anyway, I'm very partial to German Shepherds too, by the way, in case you guys didn't know that about me. So, the symmetrical figures have 2 sides that are exactly alike. Now, it's really, really important that we cut a symmetrical figure in the right place in order to prove symmetry. And in this case, oh, no, did not do it. That was a big, big boo-boo, because as you can see, both halves of, well, the sides on each side, the way it's cut, are not perfectly symmetrical. They are not a mirror image. So take a look at this one. Is this done correctly? Yes or no? All right. So reflections are another way of referring to symmetry. And this is a true reflection of a lake and the mountains and all these beautiful balloons. Isn't this just a beautiful scene? Wouldn't you love to be there? And as you can see, symmetry, we've seen it in a couple different directions, and in this case, the shoreline is the line of symmetry. Now, I know this is not perfectly symmetrical. If you look really carefully, you're not seeing the mountains the same way. The trees look bigger in the water, but it gives you a really cool view of a symmetrical, something that's pretty symmetrical in nature and just beautiful. But let's talk about how that some figures can have more than one line of symmetry. In the case of this figure, let's take a look. We can cut it across horizontally like that last picture was. But wait a minute. We could also cut it vertically, couldn't we? Oh yeah, look at that. So we've got 2 lines of symmetry here. But hold on. Do you see what else? There's another direction we can go. Look at that. If we chose to do that one, aren't those 2 halves the same? And wait, of course, now I'm sure you see the other one. There it is. So this figure actually has 4 lines of symmetry. So your question, how many lines of symmetry does this one have? All right, that was it. Short and sweet. I hope you enjoyed it. We'll see you next time. Have a great day.